Hello and welcome to this video where we're going to be looking at similar areas. So here I have three different rectangles which are all similar because if you take this 5 and double it to get 10 and you take this 2 and double it you get 4. So this rectangle here is twice as big in terms of lengths, whereas if I go from this first one to this third one here, it's 3 times as big in terms of lengths. So let me just work out the area of each of them. So the area of the first one here is 5 times 2, which is 10 centimeters squared, and the area of the second one here is 4 times 10, which is 40 centimeters squared, and the last one is 6 times 15, which is 90 centimeters squared. So to get from this first one to this second one here, in terms of lengths, I'm timesing by 2, and to get from the first one to the third one in terms of lengths, I'm timesing by 3. Now what about the areas then? So to get from this one to this one, I'm not timesing by 2 but timesing by 4, and to get from this one to this one I'm timesing by 9. So what's going on here is whenever I double the lengths I multiply the areas by 4, and whenever I triple the lengths I multiply the areas by 9. So if we have a length scale factor of 2, we have an area scale factor of 4. If I have a length scale factor of 3, I have an area scale factor of 9. What about if I had a length scale factor of 4 and I quadrupled them? Well, it should be obvious from this that it will be 16, because the pattern is that 4 is 2 squared, 9 is 3 squared, and 16 would be 4 squared. So if you double the lengths, you times 2 by itself, you quadruple the areas. If you triple the lengths, the areas go up by 3 squared, which is 9, and if you multiply the lengths by 4, you do 4 squared, and the areas would go up by 16. So how can we put this into practice? Let's have a look with an example. So here I've got two triangles which I'm told are similar. So I've got this one with a length of 10 and this one here with a corresponding length of 25, and I'm told that the area of the first one is 30 centimeters squared. Work out the area of the second one. So what I would do first of all is write x to represent what I'm trying to find out, the area of the second one, and divide that by the corresponding amount from the other shape, so that would be the area of the other shape, 30. So the area of the second shape divided by the area of the first shape is going to equal the corresponding length from the second shape divided by the corresponding length from the first shape. So what I've got here is the area scale factor. The thing I want to find out, divide by 30, and this is the length scale factor, the 25 from the second shape divided by the 10 from the first shape. Now these aren't equal. When we looked at the previous example here, we knew that the length scale factor must be squared to give us the area scale factor. So what I do is, on the length ones here, I just put a squared. Now this formula here must be true, so my area scale factor, x over 30, must equal the squared of the length scale factor, 25 divided by 10. What I can do now is very simply rearrange this to give me x equals 25 squared times 30 divided by 10 squared. And if I type this into my calculator, I would get 187.5 centimeters squared. So when we've got a question with similar areas, the first thing to do is write down the area scale factor as a fraction like this. So the one we're trying to find out, divide by the one we know, then write down the length scale factors, and of course we know both of these, and then rearrange and find out your answer, remembering to square the length scale factor. Now a common mistake that I want to draw your attention to is occasionally some people get this fraction the wrong way up. You'll notice that the missing value here on the top is for the larger of the two shapes here, and this is also for the larger of the two shapes, whereas this here is for the small one and this here is for the small one. If you were to write 10 squared over 25 squared, that would be the wrong way round and you would end up with the wrong answer. Let's have a look at a second example like this then. So here we have A and B are similar once again, and whilst these shapes are 3D, it still mentions surface area, so we can use the same rules that we just worked out. We're told the surface area of A is 30, calculate the surface area of B. So let's write down our scale factors for the areas, so x divided by 30. So the area of this one, which I want to find out, the area of this one is 30, and then our length scale factors. So I used x on the top of this one, which was for the larger shape, so the larger length divided by the smaller length. This is my area scale factor, this is my length scale factor, so to make them equal I must square my length scale factor. Then I rearrange to get x equals 12 squared multiplied by 30 divided by 4 squared, and if you type this onto your calculator you will get x as 270 centimeters squared. So once again, exactly the same approach. Write down the area scale factor with the value you need to find, and then write down the length scale factor, remembering to square it and make sure that you get the right values on the top and bottom of this fraction. Rearrange by timesing both sides by 30, and then use your calculator to get the answer, 270. Okay, here are two practice questions for you to try where you need to find out a missing area. Press pause, try these questions, and then press play and I'll tell you what the answers were. Okay, for this first one we need to do x over 900, that's our area scale factor, and then you must be careful here, we're told the surface area of A and we're finding out the surface area of B, so it's actually 4 over 12. This way around, because on the top I've got my smaller numbers and on the bottom I've got my larger numbers, and then we must square the length scale factor, so x will equal 4 squared times 900 divided by 12 squared, and when you type this into a calculator it should come out as x equals 100 centimeters squared. And for the second one here, so we've got x over 42 equals, so x was from B, the larger one, so I want the larger length over the smaller length. I must square my length scale factors, so I end up with x equals 15 squared times by 42, and then divide that by 6 squared. And when you type this into the calculator, you would end up with 262.5 centimeters squared. Okay, example 3 then. So this time it's slightly different. We have two shapes again that are similar, and this time we're given both surface areas and asked to find a length, so this is slightly different. Again, we would write out x over, but I would pair x up with 5 because x is a length and 5 is a length. So I've got my larger length divided by my smaller length would equal my larger area, which is 25, divided by my smaller area, which was 9. So again, I've been consistent and kept my larger values on the top, so from shape B, and the smaller ones on the bottom. Now, this first one this time isn't an area scale factor, it's the length scale factor, whereas this here is the area scale factor. So what I must do is square both bits on my length scale factor. So this time I'm squaring the fraction that involves the x. This is different to previous questions. So if I now rearrange, I would get x squared equals 25 times 5 squared divided by 9. And to solve that completely, I would need to square root both sides. So x would equal the square root of 25 times 5 squared divided by 9. So if you type all of this into the calculator, you will get the answer of 15 centimeters. And of course, when you square root normally, in here you might be expecting a plus or minus square root, but we know that this length can't be a negative length. That wouldn't make sense, so we just need to give the answer 15 and not negative 15. Okay, here are two extension questions for you to try on similar areas where you might have to involve some square roots. Press pause and try these questions, and then press play and I'll tell you what the answers were. Okay, so for this first one what we have is x over 10, So the small length divided by the big length equals the small area over the big area. I then square my length scale factor. If I rearrange this, I end up with x squared equals 25 times 10 squared divided by 100, and therefore x will equal the square root of 25 times 10 squared divided by 100, and therefore x would equal 5 centimeters. For this next question, I have x over 10 equals, so x is my larger length, so I need my larger area on the top of this fraction, divided by 64. I then square my length scale factor, so x squared equals 180 times by 10 squared divide 64, so x will equal the square root of all of this, 180 times 10 squared divided by 64. And when you then square root that and type that into your calculator, you will get x as 16.8 centimeters. That concludes this video on similar areas.